Hello, kids, scientists, and parents. Welcome to week 2 of the Summer Junior STEM Club program. My name is Elaine Griggs, and I am founder of CS for Youth, Computer Science for Youth. And we teach computer science in hybrid spaces to K through 12. So all age levels, and Junior STEM Club is designed for the littler ones. But the experiments are fun for everyone, including adults. So here we go. This week is the second in the series on water. Last week we did a couple of experiments with water, and this week is two experiments, really easy, so easy, with waves. So in the lesson plan, there are some pre-lesson questions about waves. Ask your child what is a wave and either let them answer or give them a couple of choices. Sometimes you don't have to ask these as multiple choice questions, but what is a wave? Is it a kind of animal? Is it a back and forth movement that carries energy? Or is it a shape to draw art? What is important is not the answer, what your children think of the answer. So if they say it's a shape to draw an art, fine, that's fine. They might learn more about waves this week. If they do say it's a kind of animal, let them explain, and maybe they would name animals that live in the waves. Which of these is a kind of wave that we can hear? A water wave, a light wave, or a sound wave? Now, if the kids say water wave, ask about that. You're right, you can hear waves down at the beach. Sound waves, you can also hear. Most of us don't hear light waves, but some of us might be able to. What happens when you drop a rock in a pond? Water turns to ice. Water moves in circles, while waves move away from where the rock landed. How do light waves help us? They make things sticky. They help us to see, taste, and smell sweet. True or false? Sound and light waves can travel through air, water, and a wall. So, you decide and talk about that. What happens to different kinds of waves in a vacuum? A vacuum being empty space, not the appliance that cleans the house. Not that vacuum, but it is the same word. So think about what you know about that. So what causes waves in the ocean? What do we know about that? The answer is waves blowing across the water and earthquakes and tides. And do waves move energy or matter? That's what we're going to see in our experiments. So we have two experiments, a wave capture experiment and wave and wind observations. The materials are so easy. Again, I really don't have them to show you because they're just that easy. So a soda or water or any bottle, fill it a little more than halfway with water, the rest of the way with cooking oil. You can add less oil and then more oil. Less oil, test it. See if you want to add a little more oil. And a drop of food coloring can make this experiment fun. All right, in the second experiment, it's wave and wind observations. The only thing you need is a cookie sheet or a plate, water, salt, and a straw. So with the wave capture experiment, the first one with the soda bottle, we're using an empty soda or clear juice bottle where I already explained, you're adding the water, filling it halfway, and then fill the rest of the bottle with oil or a little at a time, see how that goes. And then you're closing tightly. You could have added some food coloring, a little bit. Close tightly and tilt side to side to create a wave motion. Start to look at it. Okay, now the interesting part of this is that you're going to have I should have put this in the materials. Let me add them. You really do need a, what's it called? Permanent marker that can write on the bottle, because now you're going to do the learning part, and you're going to label the biggest wave that you think you can make in the system, and label the crest, which is the top of the wave, the trough, which is the lowest part of the wave. The wavelength is the distance from one crest to the next, and there is a illustration in the lesson plan. And then wave height is how tall the wave is from trough to crest. Amplitude is a little different. I wrote it in here, but we're not talking about amplitude, really. You can if you want. That's why I'm throwing it in here, is the height from the displacement. So now, optionally, you can add small shells and pebbles. So you're tracing the wave, and then labeling crest, trough, wavelength, and wave height. Now you've done that part, the drawing and the labeling, add small shells and pebbles and maybe a small floating toy, and predict before you play with it what is going to happen to your biggest wave. Does this wave get any bigger now that the objects are there? Some float, some sink. Or does it stay the same with the shell and pebble objects? You can also add a little bit of soap to get some bubbles, little tiny bit. So hopefully the bubbles are, you notice where the bubbles are when you add a little soap. You could also add a little pepper or glitter. So now the wave wind observation experiment is different. You're going to take a cookie sheet, so simple, sprinkle a little salt on the cookie sheet or plate, add water and to the salt surface, and have small objects to blow across the cookie sheet using a straw. So this is really fun for little kids, and they will do it, both things, take up some good time. Good science STEM time. Do they notice the movement of the waves moving their object? Watch how the grains move around the object. What words explain what they notice? You can add pepper, or glitter, kind of more toward when they're almost done with the pepper or glitter, because they don't want to take it up through the straw by mistake. So at the end, if you add pepper or glitter and dip the top of your finger in soap and put it in the center of the pepper or glitter, you can watch a wave spread out at the end. So optional, at the end of the experiment. You can try that one. And then you can talk about shells and sea life. I did a little bit of this. I said the experiment starts to show us how sea life is affected by waves and water movement and motion. Waves bring seashells, seaweed, and sea creatures closer to the land. Waves help sea life by moving food around, bringing oxygen into the water, carrying baby sea creatures to their new homes. Discussing the shoreline, waves shape beaches. Big waves carry the sand away, while gentle waves bring the sand in. And the shoreline changes through changing currents, water temperatures, waves, winds, and seismic activity. We can take measurements and study the data to make predictions. So this is something you can start now to do with older children, is look up the data on shoreline changes. Your journal drawing is to draw and label a wave using permanent marker. You're going to do that on the bottles, but also then copy that into the journal. And then if the waves got bigger with items in them, can they draw that change in the journal? Okay, that's a wrap, people. Less than 10 minutes with 2 really fun experiments that you can do more than one day. Have good STEM fun this summer with your kids' scientists. Bye.